25,000 years ago, the domination of the world by our species had led to the extinction of all other pre-human ancestors, the creatures who began our evolutionary journey. At a place called Taung in South Africa, archaeologists have uncovered extraordinary evidence for the very start of the human story. The skull of a young, pre-human creature many millions of years old, an ancestor from our deepest past and its hostile world.
The youngster, wandering off a little from the rest of the family, could easily have fallen a ready prey for a passing eagle. Down it came and snatched this head off and carried it here into Taung 2.6 million years ago.
Searching for our first human origins means looking for traces of a world that is millions of years old. Evidence is almost impossible to find. And the most fundamental question, why human beings should have evolved at all, is still a matter of great mystery. Scientists everywhere are looking for the oldest creatures that might still be called human ancestors. These creatures must hold the key to who we are and where we came from. And every now and then, there's a discovery. Embedded in the rock are the ghostly fossilized traces of a strange creature.
It's likely that it fell in. You see it's at the bottom of this slope, and it could have come in through the original entrance 25 meters above us, not have been killed by the fall, but actually tried to find its way out and died here at the bottom of the slope.
The layer of rock the bones come from is over 3 million years old. The lower bones of one leg have already been chiseled free, but the rest remains trapped deep in the rock. Ron Clark believes that what he has already found suggests that a complete skeleton may still lie beneath the limestone.
In the intervening space, I'm hoping that I'll find the rest of the skeleton, that is the vertebrae, the pelvis, and the upper parts of the leg bones.
The outline of a head is just visible, still connected to a thin strand of the spinal column. The teeth are clearly preserved. Here, deep in the rock, is what scientists think may well be one of our earliest ancestors, a pre-human, far away from the dark forest where its kind once lived 3 million years ago.
We study human evolution to understand who we are. And we really can't understand who we are unless we go way back to the very beginning of the journey. We need to know who these very first ancestors were, why they evolved, what they looked like, how they lived. Because without being able to answer these questions, we don't know where we began. We don't know where we came from. When people started to think about evolution, it became immediately clear to them that there was one group of animals that was the most similar to humans in their body form. And these were the primates, the monkeys and apes. This is a young chimpanzee, and you can see what they meant. In the skull, the eyes face forward. If we come down the skeleton, the hand's very similar to a human hand. The thumb's short, but it has the same type of grasping ability. It can manipulate objects just like humans can. Now, if we're going to look for the earliest evidence of the human line, it's very logical to look for this evidence in the same area of the world where you find our closest relatives. And this is why people have focused on Africa.
A storeroom near Johannesburg is home to the fossilized skull of the young creature that died at Taung. The skull has a special place in the science of human origins. It has done more than any other discovery to unlock the mystery of our evolution.
Here is the box that contains South Africa's crown jewels. The layer of rock out of which it emerged is about 2.6 million years old. The little creature, about 3 or 4 years of age when it died. That would have been a fantastic find if that's all that had come to light. But in fact, there was more.
The brain of this small creature has also been fossilized. Blood vessels, arteries, even veins are miraculously still intact 2.5 million years later. And for scientists, it is this living detail that sets the Taung child apart.
I do not think that there is another find which has made more of an impact on man's understanding of his origins, his quest for his roots.
The skull was blasted to the surface at Taung on the southern edge of the Kalahari Desert, where miners were quarrying for limestone. A few weeks later, the skull arrived in Johannesburg, sent to a man called Raymond Dart. He was a professor of anatomy, not an archaeologist, and it was something about the actual shape of the skull that first seemed strange. Although clearly ape-like, it didn't seem to correspond to any creature, past or present, that was known to science.
A person of lesser imagination and initiative might have dismissed this as a sort of beat-up chimpanzee.
The differences were minute, but for Dart, unmistakable.
he could detect that the canine tooth was smaller than the canine tooth of a chimpanzee. The face was more vertical than the very snouty face of a chimpanzee. And then on the base of the brain cast, Dart found evidence that the head had been held on a much more upright spinal column than in the case of the apes, where the column is oblique and the head tends to hang forward in that fashion. On the other hand, the brain size was ape-like, and not nearly of the size to be found in a modern human child of approximately the same age.
Sensing that this mix of ape-like and human-like features were the signs of a creature in the midst of great change, Dart realized he had discovered a new species. He named it Australopithecus africanus, the southern ape of Africa.
A creature 2.5 million years ago which had taken decisive steps in a human direction.
"300 miles from Taung, far into the northern Transvaal, Professor Tobias himself made a startling set of discoveries. They began to answer the mystery raised by the tiny fossilized skull. Why, millions of years ago, were human-like features starting to appear in African apes? What was causing the change? Here, at another limestone quarry, was extraordinary new evidence of these early apes, the strange Australopithecines. Tobias uncovered a vast hoard of fossil bones, mainly of long-extinct species of hyena and giraffe. But strangely, the bones he found seemed to have been broken deliberately, even violently. And when Tobias mentioned the discovery, Dart became agitated, traveling to the quarry to examine the broken bones for himself.
Dart became very excited by these because he thought he could detect consistent set patterns of breakage which were recurring again and again.
And you can see how it's been cut with an axe, a primitive axe, in order to give it its shaft.
And he came to believe that those were deliberately fashioned in a kind of Bone Age culture preceding the Stone Age culture.
And it could be used as a remarkable dagger and even as a more formidable club, like that.
Dart's breakthrough was known as the killer ape theory, and it was his answer to how apes became us. In creating crude weapons from bone to survive in their violent world, Dart thought the Australopithecines were also evolving the beginnings of an intelligence that would one day lead them to humanness.
This primitive hyena jaw could rip up a belly. With a weapon like this, they could gouge out the eyes of any animal.
Dart thought he had solved the mystery of how we appeared on the Earth. Apes evolved bigger brains to be better fighters, and in so doing became human. The engine of our evolution was violence. And more Australopithecine discoveries made it possible to compare their anatomy to ours.
The human pelvis is very different from the pelvis of any other mammal. It's very short, it's very squat. You can see this by looking at a ape pelvis, where the hip bones are very long and very flat from front to back. Now, the first ever discovered Australopithecine pelvis was really quite a surprise because it's very human-like in form. And this can be seen clearly if you compare it to a modern human bone from an individual of about the same size. Now, the reason this is important is that this pelvic shape has everything to do with the fundamental human characteristic of being able to walk on two legs. So what we can tell about the Australopithecines is that although they were ape-like in many features, they were able to walk on two legs. And because of this, we know that they must have played a very important part in the human story.
Just as Dart first suspected, the Australopithecines did indeed walk upright, unlike any mammal except us. These creatures could now be confirmed as the first human ancestors. But scientists had little more than a few isolated fossil bones, not enough for an accurate picture of the Australopithecines. And then, in the Hadar Mountains of southern Ethiopia, a complete skeleton was unearthed. A team of fossil hunters located the remains of what must be the most famous Australopithecine of all, a creature they called Lucy.
Most of the specimens that one finds of early hominids are just very small scraps. But occasionally fortune smiles on you and you discover something remarkable like Lucy, a little more than 3 million years old. And the chances of that happening are probably like those of winning the lottery.
At first, scientists expected that a complete Australopithecine skeleton would display further human-like features. But Lucy's bones revealed something very different.
Lucy was quite small, not much more than 1 meter in height. My finger bone, it's really quite straight. Lucy's is curved, and the only good reason to have a curved finger bone like that is that if you're clasping something. And the thing that they're liable to clasp is a branch. And if you're clasping branches, you must be living in trees. Lucy could have walked, but certainly was also very, very at home in the trees or on a cliff or on a rocky outcrop. When you take these little rib fragments and you assemble them, they don't make up a rib cage, a human sort of rib cage. They make up a chimpanzee sort of rib cage, which is narrow at the top and wide at the base. And that's the sort of rib cage you have if you have a large gut. And the reason that you have a large gut is that your diet has a lot of vegetable matter in, and you need the gut in order to digest it. And we now realize that the sorts of changes that you would need to make from a Lucy-type animal into a human-type animal are quite profound. They were not like apes in a few important ways, but in many ways they were like apes.
Small, plant-eating tree dwellers, although upright like us, Lucy's skeleton showed that the first Australopithecine ancestors were in every other way still apes.
This makes them no less interesting. In fact, it makes them in many ways more interesting, because we now have to see them as animals in their own rights.
"3 million years ago, caves like this gave shelter to the Australopithecines. But the true nature of our small, upright ancestors was being transformed by new discoveries. Dart was convinced that our early ancestors were brutal predators.
This primitive hyena jaw could rip up a belly.
He wrote about these killer apes slaking their ravenous thirst on the hot blood of victims and greedily devouring livid, writhing flesh.
For him, the fossil record contained proof of our violent origins.
Part of Dart's theory was that because one only found the skulls, parts of the skulls generally, of the ape men and of the baboons, this to him meant that our ancestors had been headhunters and professional decapitators, as he put it.
But Bob Brain wondered if there might be another explanation for the high number of skulls the archaeologists were finding.
When baboons and people are eaten by leopards, frequently the whole skeleton disappears and all that remains is parts of the skull.
And when he looked at the fossilized Australopithecine skulls, his instincts were confirmed.
One of the most important bits of evidence that made me suspect that Raymond Dart was perhaps wrong in claiming that we had been the predators, the killer apes, was this skull of a child from Swartkrans. We're looking here at the back of the skull, the two parietal bones, and these have two round holes in them. And then from the same part of the cave, interestingly enough, we had the lower jaw, the mandible of a fossil leopard, the same species as we have today. And we found that the spacing of the lower canines of this leopard matched almost exactly the spacing of these two holes in the back of this unfortunate child's skull. This made me conclude that we were the hunted, not the hunters.
Small, vulnerable apes at the mercy of predators. The more the archaeologists discovered of Taung Child's kind, the harder it was to explain how they could have been successful enough to be our ancestors. But these delicate creatures were not on their own.
Some of the Australopithecines are like the tongue child. They're very lightly built, and they're gracile in their form. In fact, we call them gracile Australopithecines.
Then a strange new species of ape man began to emerge from the ground.
Other Australopithecines were very different. They had extremely big cheek teeth, very heavily built jaws. They also had very heavily built faces, and they had this strange crest that runs down the center of the skull. We call these Australopithecines the robust Australopithecines.
The robusts and the graciles had both evolved from our earliest ape ancestors. Something in prehistoric Africa was changing. The pace of evolution suddenly accelerated, and the Australopithecines began to split into two disconnected forms. Why? At Makapansgat, in the same caves where Raymond Dart thought he had found the killer ape, archaeologist Kay Reed has come to look for clues to explain this bizarre mutation in the Australopithecine line. Channeling deep into the rock, her team has reached a level in the cave floor which is 3 million years old, exactly the same period the Australopithecines began to divide into robust and gracile forms. What Kay Reed has found are not the remains of human ancestors, but the broken bones of antelope.
What you can see up here are a lot of fossil antelopes that are about 3 million years old. These particular antelope are adapted to an environment that's pretty wooded and lush.
And clues to the prehistoric climate come from the teeth of these long extinct antelope.
These teeth indicate that there was a browsing animal. It ate leaves. Sometime during this period, this particular antelope became extinct. It couldn't survive. Its diet disappeared. And you get new antelope appearing with teeth like this that are designed for eating grass. So there's a big turnover at this time where these grazing animals replace these browsing antelopes.
A dramatic climate change transformed the dark, fertile forests to dry scrublands and savanna 3 million years ago, a change that must also have affected the lives of the Australopithecines.
This is the same situation that our early ancestors faced, and they either had to adapt or become extinct.
The Australopithecines' new environment would have been very like the African scrublands of today, harsh, dry, and with few obvious choices of food. And here, Kay Reed has looked for evidence to see what the Australopithecines might have done to survive. The only possible food sources are thick roots and tubers.
This may look like it's not very good food, but in fact it's where most of the nutrition in the plant resides, and because of the environments that these robust Australopithecines are found in, I have a feeling that this is the type of food they were eating.
This new diet holds the key to the robust's strange appearance, the great jaw and skull crest.
The crest is for the attachment of the big jaw muscles that help to move the jaw. And undoubtedly, they were able to generate really large forces between those cheek teeth. We think that they must have eaten a diet that required extremely heavy chewing.
The 3-million-year-old creature at Sterkfontein has the powerful jaws of a robust Australopithecine.
And what's remarkable about it is the massiveness of the cheekbones, this region here. It seems to have the trace of a crest on the top of the skull, indicating very powerful jaw muscles.
But if the mighty robusts could only survive climate change by chewing plant roots, what would the puny, vulnerable gracile find to eat? Then researchers at New York State University made a remarkable discovery. By coating the inside of Australopithecine skulls with liquid latex, they made a series of artificial brain casts, perfect replicas of these prehistoric brains. From the shape of these casts, they saw instantly that our bigger brain could only have evolved from a gracile ancestor. Archaeologists began to wonder if the changes that led to a bigger brain might have been caused by a change in diet.
What we know by looking at the animals on the African savanna is that vegetarians don't have big brains.
Archaeologist Tom Loy has begun to find answers in a peculiar collection of stones found alongside Australopithecine remains.
Until 2 years ago, many of them, this one, for example, was simply thought to be just a waste bit of rock.
Wondering if there might be more to them, Tom Loy examined the small stones in closer detail.
I've used a very high-power microscope and some biochemical tests and established that this part here has bone working. This has got blood and meat tissue. There's some hair in there.
Millions of years ago, these fragments of stone were covered in blood and animal tissue. And more than 1,000 miles up the great African Rift Valley, another team is also searching gracile remains for evidence of what triggered their brain growth.
Another bird bug.
Oh, wow. This is really neat, you know? Scuttlebutt.
Here at Olduvai, they have uncovered a hoard of animal bones. At the field lab, Rob Blumenschein has been examining the finds. At first sight, the bones seem to have been chewed by the carnivorous savanna predators.
This specimen shows a conspicuous tooth marking by a large carnivore, yet looking more closely, one can detect a very faint striation on the surface of the bone.
Cut marks like these are made from stones. Stones identical to those found by Tom Loy.
This specimen is a arm bone of an antelope, and it preserves a small mark on this fracture edge, which was produced when hominids rested the bone on an anvil, and used a hammer stone to break open the cavity, exposing the fat-rich marrow inside. Subsequently, the bone was chewed by a carnivore at one end.
Here in these fossilized bones is proof that the gracile Australopithecines had discovered the first stone tools and were using these tools on the bones of animals. While their robust cousins were eating tubers, the gracile had found meat. For Leslie Aiello, this was a hugely significant step.
Meat would have been very important to our early ancestors because meat is energy food and it's easy to digest. Now this is important because it would allow us to have very small digestive systems, very small guts.
Professor Aiello believes that a smaller gut would have had an impact on the brain.
Guts are very expensive in energy terms. So the smaller the guts you have, the more energy you have for a larger brain.
But how could the tiny graciles compete successfully for meat with the other predators of the African savanna?
Dark maned lion with a fairly full belly. It doesn't look like he ate last night.
The extinct volcano of the Ngorongoro is home to just the kind of predators that would once have faced the Australopithecines.
It's clear from a place like the crater, which is very open without many trees, that although there is a tremendous amount of scavengeable food available, it would not have been accessible to our ancestors without them incurring tremendous risk themselves from predation.
As well as its predators, the African savanna is also home to some of nature's most efficient scavengers.
Hyenas are very abundant in these open environments and get to carcasses quickly and thoroughly consume them, leaving nothing for a would-be hominid scavenger.
Unable to compete on any front, the Australopithecines needed to find meat where no one else wanted it.
This is a partial cranium of a wildebeest that died some time ago. The carcass has been heavily ravaged by scavengers who dispersed all of the edible parts over the landscape. Yet, even in this heavily ravaged carcass, we see that the cranial case is intact. The brain would have been available, providing about 300 grams of protein and fat. And had the carcass been less ravaged, and for example, the leg bones present, when fresh, this would have indeed provided hominids with a very substantial meal of brains and marrow.
They could crack through the bone with their primitive stone tools. And when they got to the bone marrow, they would have a very rich, fatty food that would give them higher energy, but also give them the building blocks for the growth of the brain.
With tools to get at bone marrow, the graciles now began a great journey that would take them far away from their ape origins. Experiments show archaeologists how difficult in practice it would have been for the graciles to make their first stone tools. But it was just this difficulty that made all the difference. In the struggle to survive, those graysows who were intelligent enough to make tools would have had an advantage over those that couldn't. Bad toolmakers would die off, and good ones would reproduce. Here at last was exactly the kind of evolutionary mechanism that archaeologists had been searching for.
There's a very interesting feedback mechanism associated with this. We have tools, we have meat, and we have large brain sizes. And you can't have one without the other. Stone tools would have allowed them access to this high-energy food resource, access to the meat. And in turn, the meat would be necessary for the growth of the large brain. So the larger brain and the more intelligent they were, the more efficient they were in making tools, the more efficient they were in being able to extract the meat that they needed to eat. So you had the system feeding back on itself. Once the dietary change occurred, because of the interrelationship of tool use and brain size, the stage was really set for human evolution.
Taung child, the first Australopithecine to be discovered, belonged to a species existing at the deepest roots of the human family tree. A group of ape-like creatures who, with tools and meat, had begun the long process of developing human-like brains, but who were still very much at the mercy of nature.
It's always been a very strange and curious problem why only a single specimen came from here. Why were there not others? Why did we not have the child's parents? It was a problem how this child came to be alone here in the cave. The very likely solution to the mystery has now been presented to us, and it explains the curious feature of an indented or depressed fracture which had worried me for years and years. How did that come about? It's just the sort of scar that one might expect from the great killing talon of an eagle.
The child was carried away to a lonely death at Taung. But enough of its kind managed to survive on the African savanna and evolve brains large enough to allow them to embark on the next phase of the human story. The body of a boy who died 1.5 million years ago.